In this video you will learn how to solve games, and you will learn it by solving two classical games of the game theory: the prisoner's dilemma and the battle of the sexes. If you watch the previous video, you will learn the classical version of the prisoner's dilemma, and in this video you will learn a modified version of this game. Imagine two universities and one sponsor. And the sponsor goes to each university and says this: you can take $1 million from me, or you can let me pay $2 million to the other university. What would you choose? Would you take $1 million to yourself, or would you let the other take $2? Basically, you have a choice: to be a selfish jerk or a selfless gentleman. A gentle woman, to be politically correct. So let's solve this game. This game has two players, two universities. Let's call the first university ABC University, and let's put it on the left. And let's call the second university XYZ University and put it on the top. Each university has two options: to take $1 million or to give $2 million to the other. We have 2 by 2 matrix, and we have 4 outcomes. This is called the payoff matrix, the matrix with payoffs, gains or losses to each player, each university. So let's fill out this matrix. Look at this outcome. In this outcome, ABC University takes $1 million and XYZ University takes $1 million, and each university gets 1. And in this outcome, ABC University gives $2 million and XYZ University takes 1, so that ABC gets nothing and XYZ gets 1 plus 2, 3 million. In this outcome, ABC University takes 1 million and XYZ University gives 2, so that ABC gets 1 plus 2, 3 million, and XYZ University gets nothing. And in the last outcome, each university decides to give 2 million, so that each university gets 2. Now, these two universities don't talk to each other, and even if they do, they wouldn't trust each other, because the other university can say one thing but do the other. The other university can promise to give you 2 millions but still take 1. So how to solve this game? How would you decide what to do if you didn't know what the other player will do? You will make assumptions. Suppose the other player does this. What should I do? Or suppose the other player does that. What should I do? Suppose the other university takes 1. What should I do? Or suppose the other university gives 2. What should I do? First, ABC University will assume that XYZ will take 1 million. In that case, this is the situation ABC University will face, and ABC University will have a choice between 1 million and 0. Which one is better? 1 million is better. Underscore it. Then ABC University will assume that XYZ will give 2 millions. In that case, this is the situation that ABC will face, and ABC University will have a choice between 3 and 2. Which one is better? 3 millions are better. Underscore it. And the second university will solve this game also. The second university will also assume that ABC will take 1 million, in which case this is the situation XYZ will face. And XYZ will have a choice between 1 million and 0. Which one is better? 1 million is better, underscore it. Then XYZ will assume that ABC University will give $2 million, in which case this is the situation that XYZ will face. And XYZ will have a choice between 3 million and 2 millions. Which one is better? And the cell with two payoffs underscored is called the Nash equilibrium. In our case, it's this cell, 1, 1. The first university takes 1 million and the second university takes 1 million. Now, why is this game a prisoner's dilemma? Look, is this outcome, the Nash equilibrium, is it the best for the universities? No. The best outcome for them would be this, to give 2 million and to give 2 million, in which case they would have received 2, 2, which is more than 1, 1. But they don't achieve it. They don't trust each other. Each of them is afraid that the other player will take 1. In the end, each university chooses to take 1 and they make each other worse off. And now let's move on to our second game. Imagine a couple, a man and a woman, and they want to go to an event. The man, he wants to see boxing. And the woman, she wants to see a ballet. You consider this game is sexist and it's full of gender stereotypes. What is good about boxing anyway? What is so enjoyable about watching two sweaty people pounding the out of each other? But let's go back to the traditional setup of this game. It's a bit sexist, but hey, the game is called the Battle of the Sexes, so I guess it makes a grammatical sense. The man wants to go to a boxing match, and the woman, she wants to see a ballet. And they want to see an event together, because if they go to their separate events, they will get no happiness, no satisfaction. Let's put the man on the left and the woman on the top. And they decide to go to a boxing match or to go to a ballet. They want to go to the same event. If they go to separate events, ballet boxing or boxing ballet, they will get no happiness, no satisfaction. I can get no satisfaction. I can get no satisfaction. If they go to the boxing match, the man will enjoy it more than the woman, so that he will get 2 units of happiness and she will get 1 unit. And if they go to the ballet, the woman will enjoy it more than the man, so that the man will get 1 unit of happiness and the woman will get 2 units of happiness. They can't call each other, they can't talk to each other, they can't coordinate, so the man has to make a decision alone. And the woman has to make a decision alone. Let's solve this game for the man. First, he will assume that the woman will go to a boxing match. In that case, the man will have a choice between 2 units of happiness and 0 units of happiness. Which one is better? 2 units are better than 0, underscore it. Then the man will assume that the woman will go to a ballet. In that case, the man will have a choice between 0 and 1. Which one is better? 1 is better, underscore it. Now let's solve this game for the woman. First, she will assume that the man will go to a boxing match. In that case, the woman will have a choice between 1 unit of happiness and 0 unit of happiness. Which one is better? 1 is better, underscore it. Then she'll assume that the man will go to a ballet. In that case, the woman will have a choice between 0 units of happiness and 2 units of happiness. Which one is better? 2 is better than 0, underscore it. And the cell with 2 payoffs underscored is called the Nash equilibrium. In our game, we have 2 Nash equilibria. In this game, we have 2 solutions, 2 Nash equilibria. The first equilibrium is the man goes to the boxing match and the woman goes to the boxing match. And the second equilibrium is the man goes to the ballet and the woman goes to the ballet. That was 2 classical games in the game theory: the prisoner's dilemma and the battle of the sexes. The prisoner's dilemma shows us the problem of cooperation, and the battle of the sexes shows us the problem of coordination. The prisoner's dilemma shows us the problem of cooperation when players can't cooperate and they make each other worse off. And the battle of the sexes shows us the problem of coordination when players want to cooperate, when players want to go to the same event, but they can't coordinate their actions. I hope you enjoyed the game theory because it's beautiful and it's elegant. It combines economics with psychology and it shows you that your life is a game.